All right, hey guys. All right, so here we are at 1.2, understanding limits graphically and numerically. Okay, now please don't get too bogged down in the fact that it says recall from pre-calculus that you evaluated 3 types of limits. You didn't have time to do that. All right, pre-calculus was jam-packed with stuff, and you didn't have time to get to this. It's no big deal. On this first page, we're just going to write the notation, and then as we move on, we'll talk more and more about what it means. Okay, so just hold on. Don't get too upset right here at the beginning, thinking, "Oh my gosh, there's something that we were supposed to know." That is not true. You are perfectly fine as you are. Okay, so here, let's go purple. All right, so here we go. The first thing is called a right-hand limit. So I'm going to write the notation. I'll say it in words, and then we'll talk more about it as we move on as to what that actually means. Okay, so it's always kind of it's lowercase. I kind of do it almost like I'm doing cursive, but I'm not. This is just what I was used to when I first learned calculus. You can just make that an L, but you might want to make it look like that so somebody can actually tell that it is an L. All right, so it is the limit as x. I'll say x is my variable, and then f of x will be the function we're talking about. So it'll be x as x approaches. So this is an arrow. That's an arrow. Some value, okay? And down here below, we'll have actual numbers, but for the time being, we'll just say C, all right, from the right, okay? And there we go. Now, and f of x is the function that we're talking about, all right? So now, right now, you're like, what the heck are we talking about? This is a plus sign right here. It's kind of bad that looks so bad the first time I wrote it, but there we go. So we have LIM for the limit. X is approaching, this is an arrow. C from the right, that's a plus, doesn't look like it. And then there's the function we're talking about, all right? And as far as reading this, it is read, the limit as, I'll put this, of f of x as x approaches, in this case, C from the right, okay? Boom. That's how you say that. All right. That's how you say it. All right. And so then for our left-hand limit, and again, don't worry, we're gonna discover what this is talking about really, really soon. All right. So all right. So for the left-hand limit, then let me try to be careful here. It is LIM with a subscript below it. All right. And that subscript is x approaches, so that's an arrow, C from the left, and then our function is f of x. And so I've always read this. Sometimes you'll see it read without saying the f of x, the limit, and they'll say without this of f of x part, say the limit as x approaches C from the, in this case, left. So that's a little minus sign, almost like an exponent, superscript there, and that's our notation. All right, so here's how you read it. The limit of f of x as x approaches C, whatever value that'll be, they'll tell you a number in most cases there, from the left. So coming from the right, from the left, all right, we need to think of that as traveling, all right? And so then in general, all right, we'll have no left or right, just in general, the limit as, so LIM for limit, as x approaches C, okay, so no plus or minus this time, just as it approaches C, of f of x. Okay, and again, that could be said in a couple of different ways, but I tend to say it like this. The limit of f of x as x approaches C. Boom. Okay. Now, and you're probably thinking, what the heck is this even about? Why is this a thing? Well, you'll see, because like in pre-calculus and algebra 2, just look at this graph. This is the graph of this function f of x. It's got some issues. Okay, and we're going to talk about these issues as we go down through this part right here. For example, 1. All right. Obviously, there are a couple of asymptotes. I see a horizontal asymptote this way. I see a vertical asymptote this way. and it looks like there's an actual hole in the graph. What in the world is going on with that? Well, we're going to discover all those things through these 6 things. Okay, so the first one is to factor and simplify. So if I take f of x, let's go red. All right, and I factor the numerator. We're hoping that it factors one of its factors, or more than one of its factors in the numerator, will be the same as a factor in the denominator, and they would be allowed to be reduced. That's where the simplify part comes in. So, and I know Ms. Capps showed you the slide and divide method and all of that, and that's good. But this is one I think you probably could do. Oh, there we go. There we are. There we are. No, I need writing. Right and red. There we go. Okay, so our numerator, we know we got to have a 3x, right? And we know that and also know that the other one, binomial, is just going to have an x. Okay. Now, to get a -8, I mean, I'm going to have to build it from a -9, and the only way to get a -9 is to put the 3 here. This is the kind of just figuring it out as I go. Now, slide and divide, we can talk about that. I just didn't have room for a whole lot of stuff right here. So if you'll check me, you'll see that indeed does factor as such. Now, the denominator, though, is a difference of 2 squares. So it may have been a little while since you've had this, but that factors as x plus 3 and x minus 3. Okay, there'll be a little bit of factoring we'll have to do here at the beginning, and then you'll see that there'll be some shortcuts along the way. Okay, now, so indeed, these two factors are identical to one another, so I can simplify this fraction. Now, the only time I can't deal with that is when x is equal to 3, because I'll have that 0 over 0. We talked about that a little bit the other day. 0 over 0 is bad news. Okay, so this does simplify down to 3x plus 1 divided by x plus 3. So there we go. So the cool thing is this does not have the hole in the graph. At x equals 3, this one's perfectly fine. I've got a denominator of 6. I've got a numerator of 10. Let's keep that in mind for just a second. So I've got 10 over 6 as what it would be. But that's not the original function. The original function had a major issue at x equals 3. And that issue, because these two cancel out, is a hole in the graph. All right. Now, I couldn't get rid of the x plus 3, which has a major issue at -3, because you would have a 0 in the denominator only. That creates your asymptote. Okay. So, we just said this. The coordinate of the hole, I was able to find out after I simplified the fraction. Then I could substitute in the 3, whereas I could not here because I do not know what 0 over 0 is. All right. So 3 is where the issue was. Okay. And then it's just a matter of substituting. All right. 3 times 3 is 9. That's 10. All right. I'll leave it like this just for the time being. And the denominator is 6. But hold on a second. That does reduce, right? So instead, I could say, that's weird, but it's the same as 5/3. Okay. Yay. Domain. All right. So domain is what x can be. All right. Now, they used a set notation on that, on the key. I like saying it's all real numbers except for 2 things. All right. All real numbers except where this asymptote is, which happens at -3. And also, I do not have anything on the original graph right there at +3. So I think I would say, I'm going to type it, all real numbers except 3 and -3. All right, what about the range? The range, it's asking what y values are we going to have? Well, we have a horizontal asymptote, right? Ignore the bell. So we have a horizontal asymptote, which means that this graph approaches from below and above this horizontal line. And that horizontal line, if you recall from Algebra 2, you will ignore everything but your highest powers. It's y equals 3. All right, so my range is all, oops, learn how to type, real numbers except 3. Remember, domain's x, range is y. All right, vertical asymptote, we kind of talked about this. This is what makes the denominator equal to 0, but not the numerator, okay? That was where the hole was. All right, so that's at x equals -3, Okay, that's when the denominator is equal to 0, but not the numerator. And horizontal asymptote, as we just talked about that a second ago when we were talking about the range, and that would be the line y equals 3, because that's what you would get if you were to ignore all but the highest powers here, because these things will become insignificant. I'm talking about the negative 8x, the negative 3, and the negative 9 will become insignificant as x gets larger and larger. And really, you'll just have 3x squared over x squared, which is 3. All right, there we go. Done with that.